Jacob, Saul, and our guest Vikram is excited for this. So good morning, good afternoon, good evening, wherever you are. Want to welcome you and thank you for joining us. We're happy to have you. We're going to kick off the community conversations on Dynamo. Boy, I've been out of this for a while. Slides are going all over the place. Is that you, Jacob?
That's me. My mouse is pushing me all over the place. I think I've got it under control now, I hope.
Between that and the hand pie got me. So community conversations provide opportunities for engineers, designers, artists, and makers to meet in a safe, live virtual setting to share expertise and to get to know leaders in your field and grow our community network. The sessions are always supported by Autodesk community managers to help guide the conversations, feed important insights back from the community to Autodesk, and support participants in getting connected to the expertise you need. All right, fun stuff. Before we begin, we have a few light rules. Everyone's line is muted. That's to reduce the background noise. We invite you to turn on your camera if you feel comfortable with that. If you have a question, raise your hand using the Zoom hand or ask in the chat, and at times we will take those questions and answer them as we go along. This is a conversation. It's not a technical presentation. So bring your conversation to this. The session is being recorded and a link will be sent to you afterwards, so you can share it or if you miss a piece of it. Next, fun from the lawyers. So just a quick note on our safe harbor statement. If we make any forward-looking statements, we want you to make your decisions on the product based on the state it is in today. That's all that is. All right, I'll introduce myself. I'm Sean Hurley. I'm the Autodesk Community Engagement Manager. I've been at the company a long time, worked on different product teams and everything. I'm a geeky technologist and I'm based in Wildfire Smoky Bend, Oregon. Hopefully the smoke is gonna blow away today though. That's fingers crossed. Jacob.
Cool. So I'm Jacob Small. I'm a designated support specialist focusing on generative design and BIM out of Autodesk Boston office. You may have seen me on the Dynamo BIM forums. I spend a lot of my free time there. Been with Autodesk about 4 years now, exclusively in this role. Sol?
Hi, everyone. Pleasure to have you here today. My name is Sol, and I'm the Dynamo product manager. So it's my responsibility to guide the evolution and the progress of Dynamo as we move into the future. So awesome to be here. I describe myself as a curious human being, have been here at Autodesk for almost 3 years, and am based out of Boston, Massachusetts. Vikram? Oh, you're on mute.
Hi, I'm Vikram. I'm an architect based in Bangalore. I've been on the Dynamo, I've been active on Dynamo forums for a long time now. It's distracted me so much that it's consumed my life. And it's been good. It's been a good, fun experience, and I hope to share some of that experience here today.
Welcome. Thanks for joining us.
All right, so thank you everyone for joining today, and special welcome to you, Vikram. Thank you for participating in our DesignScript session. So today we're jumping into design scripting all the things. So this is the session 16 in our Dynamo Office Hours series. If you haven't seen a previous series, there is a link that will get posted into the chat at some point today that has a YouTube playlist of every other session, and this one will be added to that playlist too. So as per usual, we will have a presentation that's going to be around about 20 minutes, maybe a little longer today, a little bit of a live demonstration where Jacob's going to break things in front of you, and then a bit of a Q&A session. But as per usual, if you do want to ask a question during the session, please do. And please either raise your hand, as Sean mentioned earlier, or simply write in the chat, and we'll endeavor to answer them on the fly.
Cool. So what exactly is DesignScript? It's one of the things, anytime we introduce this to somebody, that's basically the first question that's out there. And effectively, it's the engine that runs under the hood inside Dynamo. It's a functional coding entry point that allows you to basically build code as if you were writing in any other application. It enables all sorts of new expanded capabilities that you can't access with nodes directly. We'll get a little bit more into why that is later. And it also allows you to grow. And that's really one of the key tenets when I went back and did some review of the history of DesignScript. It was sort of to allow people to start in this visual programming environment and slowly learn how to write more and more and more complex code.
Yeah, and to jump on top of that, DesignScript was designed with designers in mind. So yeah, the way you think about things inside of the AEC space is the way that DesignScript endeavored to be built. So if you're thinking about the breakdown of geometrical pieces such as lines and curves and solids and surfaces, the language that is used is there to enable you to understand sort of almost intrinsically how those pieces go together.
Cool. So the big entry point into DesignScript are code blocks. And you can see down there in the lower corner of that image, we've got two different doors opening into the room. This is the room that is the creating a point through XYZ coordinates, right? And we can do this two different ways. We can use a node, or we can use DesignScript. It's calling the exact same function, giving you the exact same results, but just doing it so in a different way. So nodes call those functions through the visual interface. We wire in what we want those inputs to be, and we go from there. Code blocks allow us to call those same functions through DesignScript directly. They also allow some new features that you don't have access to through basic nodes, such as recursion, imperative code, which is a huge benefit, looping, creating definitions, more lacing options, and a whole lot more of really cool stuff.
Awesome. So jumping into a few relationships. So this is how DesignScript has its fingers in many pies. So I guess back to your analogy earlier, Sean, around pies today seems to be a thematic we have. So DesignScript, the syntax on DesignScript is actually on the majority of nodes inside of Dynamo. So if you hover over pretty much every node, with the exception of some special cases, mostly being UI nodes, which behave in slightly different ways, you should be able to see the actual syntax on how to call that node inside of DesignScript at the base of the description field. So if you look at the green circle around a node in the upper right, this is showing you exactly how to call the cuboid.byLengths node itself. What's also really important to note is that the nodes themselves are typically named in the way that you would call them also. So cuboid.byLengths is the same thing you would type into a code block to access cuboid.byLengths. And there's some interesting features that help you with that, which we'll touch upon in a little bit. So all nodes inside of Dynamo, regardless of the flavor, interact with the DesignScript virtual machine. So there's a few exceptions to this, but generally speaking, a lot of these nodes are actually converted to DesignScript and then ran through the DesignScript engine when Dynamo executes the code that you have. Zero touch nodes execute in the .NET virtual machine, and that basically talks to the DesignScript virtual machine. And they basically transpose data between themselves to give you the result that you want inside of your graph. And then all other nodes are converted to a series of different sort of languages, lower level code is what we typically call it, that is then executed in the DesignScript VM. It's rather technical, but suffice it to say that DesignScript is an integral piece of how Dynamo operates and works. And so if you start to understand how to use the nodal landscape, you'll notice that there's a very tightly coupled relationship between the nodal landscape and DesignScript itself, and you can relatively easily interchange between the two from a thematic perspective, understanding that the way nodes are called and the way nodes are written is roughly the same as they are inside of DesignScript. So just like any other nodes inside of the library, also in terms of DesignScript, the namespace relationships persist as well. So that means you can also call parent functions on children objects. So if you're present in previous sessions, we talked a little bit about this, but essentially you don't need to have a line.length node to be able to call the length of a curve. You can use the curve.length node, and you can use that on top of a circle or a polygon or any other shape as well to get the length. We also have a couple of different helpers that help you access DesignScript and sort of get your head around how to start using it. So code blocks are a fast way to input static input. So the most common and sort of lowest level access point to DesignScript is simply using a code block to put in information. So instead of using, say, a string node or a number node, you can simply left click on your canvas twice and it'll access the code block, and you can put in things such as strings like hi, or numbers or Boolean operations. And this is very typical inside of the Dynamo ecosystem. A lot of people use this, which is awesome. But if you wanted to go a little bit further and you wanted to start using DesignScript inside of a code block to actually call functions, you get access to two different helper pieces of the puzzle. One of those is called autocomplete, which is in blue right now. So if you start to type and grammar matters here, and Jacob's going to talk about that later. But if you start to type something such as point, it's going to give you every single option, or PO in this case, every single option that has PO inside of it, to start to expose to you all of the options you have inside of this sort of inside of the Dynamo world, which are all accessible in nodes, or in this case also through autocomplete and DesignScript. And then after you have chosen the method that you want to call, if you use a period at the base of that, it gives you access to dot notation, which also helps you with all of the different ways that you can play with that function, through methods in this case. So point will also give you access to, say, by coordinates, origin, by spherical coordinates, and so on, as well as some of the properties such as X, Y, and Z. And then the third helper is node to code. So Dynamo has this really awesome feature that if you have nodes inside of your graph, you can simply select them all, as is in the GIF at the bottom, that allows you to then right click on the canvas and use this feature called node to code, which is going to convert every node that is convertible, in this case, back into DesignScript. So it's not necessarily going to be the most legible or efficient way. It's just going to be a representation of DesignScript. You can write it in different ways, but it is a pretty awesome way to go and start learning how a particular node may express itself inside of DesignScript and start to educate you and teach you on that syntax.
So the way we initially get started with actually writing DesignScript is putting that first code block on the canvas. There's two ways to do that. You can either just double click anywhere on the workspace and you'll get that lovely little code block, or you can find it in your library, which is under script, editor, code block, right over where we've got our Python script nodes as well. Once there, the DesignScript just gets typed up inside that. Your code goes here, and we'll show a little bit more on that in a few. Now, this slide is big and messy, and there's a lot going on because there's a lot you can do with DesignScript, right? Everything starts with that initial code block node, and then you just sort of build up from there. A growth plan to sort of master this content, similar to how you might be trying to master nodes in Dynamo, might basically follow the exact same workflow, right? We're going to start with kind of figuring out code anatomy with our grammar, talking about how to make documentation, talk about different data types, operators, lists, dictionaries, classes, and functions, replication, and then we'll continue well beyond that into stuff like how to make custom definitions, how to leverage imperative code and alternate back and forth between imperative and associative code as well. This is the basic grammatical sort of syntax of your typical code block statements. And it does wind up that, yes, my high school English teacher was correct. The grammar does matter. This stuff is important. So try and follow along with me here, even though as we diagram out this sentence, it might get a little bit boring. This first piece that you see here, highlighted orange, is basically our statement. Any completed statement will have an associated output. That basically the entirety of what the result of that orange box will get pushed over to the little caret that goes out the other end, and then allow you to leverage the result of that statement elsewhere in the visual programming environments. Statements consist of a variable which may or may not be defined. If you do want to define something as a variable, type the name of the variable. Note you cannot leverage any of the utilized classes as a variable name. So you can't use point with a capital P, but you could use point with lowercase p, followed by the equal sign. Once that's done, your variable is defined, and you can fill out the expression that you want to use to define what that variable is. In this case, I'm going to multiply A by B by C. And what A, B, and C are, since I haven't defined those variables previously, they become inputs, right? So that content maps back over. Now I can wire in A, wire in B, and wire in C, and leverage that code in the exact same way. At the end of our statement, we do have to have an end of line marker. This lets Dynamo know that it's time to put in that output, evaluate that statement, and we'll set this variable to the value that it wants to be. We do use a semicolon for each one of those. And then the last piece, and if you're in an older version of Dynamo than what we are using lately, and I believe 2.10 this came out, I might be wrong, it might have been 2.9. Sol's nodding his head yes. We get line numbers, which can really help you sort of identify where stuff is happening inside the code as you work stuff through. All right. All of that comes together to look basically like this. You can sort of track back to where that may be. And remember, our unnamed or undefined variables do become inputs, and the results of our expressions do become outputs. Looking a little bit further at data types, integers are not doubles, are not Booleans, are not strings, but everything is var. What I mean by that, variables can be hard typed in DesignScript, but they need not be. Most of the time you can leverage DesignScript without hard coding what those variables need to be. Doubles and integers will happen by default when you start to type numbers. They will get that nice blue color. And then you can also use quotation marks to define strings. Make sure you have both a starting and an ending quotation mark for all contents. Booleans will also happen by default. So if you start to type true or false, as will null. But if untyped, everything is going to be treated as a var so that it can sort of be used elsewhere. Generally speaking, you don't have to take advantage of this, but it is really, really useful if you start to get into custom nodes and definitions.
Yeah, and to touch upon that, there's some funky things you can do with this by feeding in a series of doubles and integers mixed together, and you can actually force those to turn into or convert into an int using this kind of feature too, if you want to. But it doesn't necessarily round in the way that you want it to round, so use at your own caution.
Very good point. Next key piece to know is operators. How do we do math with this stuff? Because math and logic are a must in a programming environment. So we've got our operators: addition, subtraction, multiplication, division, modulo, which is really, really useful. A lot of people don't realize what it is. It basically gives you the remainder after doing division. I use that all the time when I'm doing animations, such as the one that we see in this example. We've also got logic. We've got and, which is 2 ampersands equals. Note it is 2 equal signs, not a single equal. If we set a single equal, it will set the value of A to be B. Notice that code block on line 7, we have A single equal signs B. I don't have an input for A anymore. I've set A to be equal to the value of B, right? However, generally speaking, if you wanted to check for equality, you would just use that equal sign, right? Double it up. Not equal is going to be exclamation point equal. Greater than is the greater than sign, less than is the less than sign, and greater than or equal to and less than or equal to are greater than equal sign, less than equal sign. After that, I want to talk a little bit about lists. Collections are really, really important to leverage in computation, after all. So lists consist of basically variables or values that are sort of wrapped inside square brackets. You can hard code them. You can use variables inside there, whatever it is that you may want to do. Note, if you were using a version prior to Dynamo 2, you would use curly brackets as opposed to square brackets. You can then retrieve any item from a list by using square brackets plus the index that you're after. In that little animation down below, I'm taking the current time on the system, dividing the number of seconds in there, or sorry, using the modulo function on the number of seconds in there by 5. So I'm going to always have a value between 0 and 4, and then pulling the index from 0 to 4 for that individual list by using I as the index that I'm pulling in that last code block. You can also leverage negative values, as you can see I did in that code block in the middle right there, where I said index -2. This is going to give me not the last item, but the second to last item. You can do -1, -3, -5, whatever it may be. There are some limitations to that, so be a little bit careful and test it as you leverage it. And then next up, we've got dictionaries, all right? We don't want to forget about this really, really key organizational tool. They are initially defined by curly brackets. So we've set the value of A, or the variable A, to be equal to a dictionary, curly brackets, where I've set key 1 to be the value of 1, key 2 to be the string, the second key, and then key 3 to be the value of 3.14. We can then pull any individual value out of that list, similar to what we did with lists, where we sort of start the square brackets, and instead of typing the index we're after, we're going to type the key that we're after. So if I pull key 2, it will return the value of key 2, which in this case is the second key.
Cool. So now that we've learned a little bit about some of the basic building blocks of DesignScript, sorry, back up, Jacob, one. We have, when DesignScripts are sort of easier than nodes, this is a few shortcuts. So DesignScript uses some really awesome and powerful range and sequence notation that enables you to do some really cool things that are arguably more powerful than nodes. So the DesignScript range sequence in particular, so the one which is bounded by the green box, showcases the ability to do a sort of generate points on either a surface or a curved domain between 0 and 1. And it's a very easy syntax to use inside of Dynamo. So this is 0.1.4, which simply means start at 0, end at 1, and give me 4 equally spaced items, including the end 2 points. So if you try to build this inside of Node, you can do it, but it's just a little harder and you have to do some rounding to get to that point. So you can also access some really cool things, such as funky alphabetic letters if you want to. So in the orange one down below, we are using a sequence as opposed to a range, where we're starting at A. We want to have 400 of those things, and we want to do steps of 1. So in this case, we can then start to get some really interesting characters that come through from the character class inside of Dynamo. And if you use one singular piece of DesignScript after this presentation today, then I would suggest that you should really look at using the numeric ranges. So the 0.1.4, it is something that I basically can't go without when I use Dynamo these days. Beyond simply using a code block to enter basic information, this is something that could be really, really, really useful for you in your Dynamo journey, as it opens up many different possibilities. What DesignScript also does is enables you to do nested if statements. So if you're building a graph in a flow that needs to have different things happen depending on different criteria, DesignScript might be a good way for you to achieve that. So in this case, we just have a bunch of jumbled numbers inside of a code block as input, and this is going to start outputting 3 different string representations for those numbers based on some conditions. So if the input number is greater than 1, and also, so it has to be true for that, and also less than 3, then it's going to output inside as the result. Then we're going to do a colon, which means then if the false condition happens, do something else, and we're going to do another condition. This is all in one line, but to get it on screen, I wrapped it down to a second one, which says if the input condition also has a modulo of 0, which means no remainder, then it's going to be an even number on the outside. And then false, if it passes or fails both of those 2 tests, it's just going to be outside odd. What this basically means is that you can get a bunch of different outputs using one simple, relatively simple, touch wood, code block input that deals with nested if statements in a pretty cool and funky way. This is a little bit more advanced, obviously, than doing the numeric ranges, but it is something that can also be extremely powerful depending on what you're trying to achieve. And beyond shortcuts, we also have power-ups. So when DesignScript can be more powerful than nodes, and Vikram's going to touch upon this a little bit further down in the presentation, but what DesignScript also enables you to do is do inline statements. So inline statements are the ability to sort of nest things within themselves. This has the saving screen real estate and space, which is kind of awesome, but also enables you to get to the heart of what you're trying to do. So on the bottom 3 sort of representations of a code block, we have a few different instancing methods, some of them inline, some of them not inline, and it shows you the ability to call both methods and instance spaces inside of DesignScript. So when we say instance, we mean calling it on a specific thing. So on the right, on the center, so instance representation of DesignScript here, we're using pnt.z. That means we're calling it on the variable pnt above. And the other expression of how to do this would be on the left to it of xval equals point.x with the brackets of p and 2. Suffice it to say that this basically is 2 different ways to call things. They're relatively similar when it comes to efficiency, so don't worry about it too much. They're just expressed here to show that there's multiple different ways to write DesignScript. And when you start to look on the forums for inspiration or look at some of Vikram's really cool stuff, you might see both of these 2 different approaches represented. And then in terms of replication, replication is a way to control the data and the way the data interacts with itself. So in the GIF on the right-hand side, we're going to notice we're putting in some braces, in this case, triangular braces or chevrons. And as we do this, we have numbers inside of these, and that's going to dictate the hierarchy of the information that is coming through into this code block. So the number doesn't matter apart from the fact that it's relational to the other numbers in the piece. So you could have 1, 2, and 3 would be exactly the same as 1, 17, and 405. It's basically a hierarchical representation against each other. But what it does, if you're noticing in the GIF closely, is it tells you which data has dominance inside of this data hierarchy. So even though the graphical representation or the geometrical representation might be exactly the same thing, you'll notice that the X value is going to change to the Y value and showcase how that data is created. But we can touch upon the depths of that a little bit later. Cool. So definitions, functions. This is how you define some stuff inside of DesignScript. So DesignScript enables you to create these things we call definitions, prefixed by a DEF, which turns purple, also or otherwise known as functions. And these are embedded inside of your graph space. So there's no wires needed, which is kind of cool. So if we create a function called pi, which simply returns 3.14, we can call that pi from any other code block anywhere inside of Dynamo with no wires attached to it. And it's going to understand the reference to that definition itself. So the two upper right code blocks here will showcase that happening. There's no connection between them, but Dynamo understands that the pi function is being called from the pi definition that is also inside of that graph space. They also show up inside of autocomplete lists after you have defined them. So I've defined a slightly more complex definition called center point, just to get the center point of a curve. And that's going to start to show up, as you see in red, inside of autocomplete inside of Dynamo, which is kind of fun. What definitions allow you to do, generically speaking, is process large amounts of data and only really return the result that you want. And this is some sort of minute benefits here, which is things like saving on rendering resource and some memory consumption and screen space. It's also a way to clean up your graph, have less wires, and have more embedded power in a way that you might not want other users to interact with, where you can leave the nodal expression to be a place for other users to start making changes and interact with those changes too. The one caveat here is it's a little difficult to debug currently. So if there's a failure point happening inside of your definition, you're not going to get that much information coming out the tail end. So our bad on that, apologies. We do need to do some work on that in the future, but there are resources out there that can start helping you resolve these kind of problems, as well as lots of friendly people on the forums who are more than willing to answer these kind of questions.
All right, let's talk about associative versus imperative code before we start to really push things further here. So this is going to get real nerdy, just as a heads up. I knew it as I was writing it, but I couldn't help myself. So functional programming is what most of us are initially familiar with. The results are independent of whatever the external state may be. Flow control is done by evaluation of the expressions sort of sequentially in one run. A good example of this is Excel. Right? Excel can't use lists. It can't iterate over a series of values in a range typically. It does, however, fail quite readily. And if you fail in the first function that you write, the 15 functions that eventually refer back to that will also fail, right? It's one continuous loop of code that runs one end to the other. The next type of programming, imperative programming, right? This is basically a result of sort of consistent changes to data that's stored in memory or on the processor as it runs things through. Flow control in imperative programming is done through if-else nodes and or loops, so we can work with lists and sort of manage that data in a way we might be a little bit more familiar with as Dynamo users. An example of this is Python, right? Most Python code is built with the imperative sort of way. There are some exceptions to that rule, I guess, but nothing that sort of holds true constantly and consistently. And then we've got associative programming. This is effectively functional programming that adds some additional flow control for replication guides. An example of this, well, Dynamo, that's what we've been talking about, right? This is really sort of specific to the DesignScript language, in that it's going to allow you to leverage lists and stop the program as soon as it runs into an issue and just pass that null real fast throughout the entire graph. However, it's not going to know to stop something when a certain condition's been reached. There's no way to sort of imperatively continue this until the code reaches a certain state. And that's where code blocks come in, right? So don't forget about them. They're going to allow you to basically insert that handbrake that says, hey, we've found the condition that causes this to happen. So let's stop running the code and then move on, pass the data off to the next node as may be. All right. There is also an awesome paper on this right here. I've linked to it down at the end, down at the base there, papers.commitpad.org data/work/att/Acadia 1453 content PDF, which had a really great breakdown of what all these different programming methods are. I didn't even talk about object-oriented programming or anything like that, because technically they all do a little bit of that, but it is there if anybody else wants to geek out just like me at a future date. On that note, Vikram, we're into your stuff.
Okay.
Yeah, there you go.
As Jacob said, I mean, this can get a little nerdy. I mean, but if you want to kind of look at the difference between associative and imperative, I mean, by default, we work with an associative style in Dynamo and DesignScript basically. And more often than not, I think the power of or the magic of DesignScript lies in the associative mode, because the features that you have with imperative, you also have with Python and things like that. Okay, so it is a lot more fun to work with replication guides in associative mode than to go back to a default way of thinking in the imperative style. Okay, but that would take some practice, and I think most people, so when I see some questions about what's the difference between Python and DesignScript and things like that. Now Python is mostly imperative, and now if you want to, if you want a kind of example as to what's the difference between imperative and associative. Now let's say we've got grains of sand, and we want to kind of pick out the large ones from the small ones, from the little ones. Now, with imperative programming, you look at it as going at it with forceps, picking up each grain, checking it for size, and putting it in a certain slot. And say if it's associative, what you're doing is you probably put all the sand in a sieve, and the grains of sand that filter through are the ones that you want. So you're kind of doing it at once. Or another analogy would be like, say you have about 10 blocks, or any number of blocks, all painted white. And now let's say you want to paint every second block red or a certain color. In imperative, what you'd probably do is you'd pick up each block, and keep one block, pick up the next one, paint it red, pick the next one, don't do anything, and you'd go about doing things like that. In associative, what you'd probably, I'm trying to create a mental picture basically. Associative, what you do, straight away, every alternate block, you paint them red. It happens in one shot. Okay, so that would, if you want to try to have a mental model of what's the difference between these two, that is it. Okay.
Yeah, that's a great. That's a great sort of analogy. I really like the sand analogy, where with the sort of the idea of this grain of sand, you have to tell the computer in Python to go through and pick up each grain of sand, make the evaluation, and then decide which pile it goes into. Whereas with DesignScript, you're just going to say, here's the evaluation that you're going to run. Go ahead and do it for all the sand, because it takes care of that, the lacing sort of automatically through the replication guides.
So in some sense, you're creating a template to apply to a data set, and then you get a result out of it. Those templates are basically, the word template is again an analogy for the functions that we define. Okay, so the thing is, we can do any task. I mean, or most tasks can be done in both an imperative style and associative style. It's usually what crisper with an associative style, but it can always be done with imperative. But the reverse is not always true. You can't do everything in the associative mode that you could probably do in the imperative mode, which is why imperative is imperative. I mean, required. Okay, so but the combination of the two, which I think I've kind of said in the next slide. Yeah, the combination of the two works extremely well. It becomes super powerful, and it is a lot of fun, really. And as designers, especially when you're trying to think intuitively, the replication guides and the associative style, I think, suits you better. But if you want to achieve a lot more, and if you get into scientific programming and you want to try to do something mathematically and things like that, I think the combination of the two works really well. And these are examples of how you apply mathematical concepts to design solutions or processes and things like that. This is actually something that Marcel on the Dynamo forums kind of got me into, these the Pisano period. Basically, I mean, he wanted to know how, and it's very nice. I mean, it's very nice to see people on Dynamo forum like Marcel and things like throwing out challenges and things like that, and helping us discover things that we probably wouldn't have known otherwise. So it's a beautiful community there. I mean, and it kind of encourages people to try things that you wouldn't have tried otherwise. Okay, this is an example. This is one of the few projects which I've done. This purely DesignScript. There is no Python or any other language involved, and this is a design automation project. It automates retail space design, retail space layouts, and based on the position of, there are lots of rules, many rules based, and the sequence and the flow and all of that is kind of handled with DesignScript. Just with a click of a button, you get the layout for different floor layer. For different shapes of rooms and things like that. And it takes into account column space, column positions, aisle widths, and different. There are categories that need to be in a certain flow in retail. All of that is taken into account, and all of that just happens in those blocks of code that you see there on screen.
Yeah, so you can really see there's lots of potential power for leveraging this to really push out some amazing examples and really simplify overall workflows. Let's transition into our live demo portion. I'm going to go ahead and, it's the wrong Dynamo. All right, hopefully everybody is seeing my Dynamo screen, and we're going to start by just building a quick surface. And I'm going to start with nodes similar to what we did before. We'll start a rectangle by width and length, right? So just a standard node, and we're going to make this rectangle 100 by 100. We can make that any size we might want. And I'm going to copy all of these down. We're going to make a second rectangle that is 90 by 90, right? So we've got a good sort of mix there. We'll then create a surface by patch to build a quick surface for the overall outline. And then one more piece here, we're going to surface.trim this with some edge loops. To do that, I need a list. There we go. I'm going to take my overall perimeter, and this is a key thing. A lot of people don't realize how this node works. You do need the outside curve loop as well. We'll wire our surface in and then our loops, and we've built our basic surface. I'm going to hide all of this geometry and preview just this one. So you can see I've now built my rectangle with sort of a hole in the middle, and we're going to try out node decode. I'm in automatic here. We're going to right click on our desktop background, and we're going to say node decode. And all of that content just gets packed out into just this one quick shape, right? So really powerful. I'm going to disable all my preview on this. And we'll put a second code block in. I'm going to define A as a variable, but not set it to be equal to anything, which makes it so I have an input. And now I can quickly preview that surface. All right, so now from here, what if we wanted to create a bunch of points on this surface? Let's say we wanted 100 points that actually fall on the surface, right? Well, that's easy enough. We could do, but randomly spaced. We can make random shapes pretty easy with a math.random node. And we'll do actually a random list, and we want 100 of those. So we'll give it one for our U value and one for our V value, and then surface. Point at parameter, take our surface, our U value and our V value. And notice I've got a whole bunch of points that don't fall on my surface, right? So the key piece here with this is how would we tell DesignScript to say, continue sampling random points until we had enough points on our surface. So the way I do that is I would use a code block. I'm going to go ahead and delete all of this, and we're going to start a new imperative code. So I'm going to start right off by saying I'm working in imperative. Once we start imperative, we need to set up what we want it to return inside of those.
Grammar is important, Jacob.
What was that?
So grammar is important. Spelling.
Grammar is important, right? So now this is automatically going to return 1 because I set that in there. And I've got my curly brackets that are telling Dynamo everything that we're going to do line by line. Don't skip any step. If we get an error, just keep proceeding. We are telling you the series of the sequences of actions to run on the data, as opposed to saying just run all the data through and let it sort of fall through the filter. So we've got to start picking up those individual pieces of sand. So if I had a target of, we said, I'm going to say 1,000 points, and I wanted to attempt to make this happen, I'm going to set this attempt to keep Dynamo from getting into an infinite loop where it might continuously sample and never actually reach my target. I'm going to set a maximum number of attempts to 10. And we can change these values later. I'm going to set I to be equal to 0, right? And this is going to be sort of what I'm going to iterate over and count my number of attempts with I. And then I need to set a value to return my list. And I forget who it was in chat, but said a lot of times when I've written my for loops, I'm only returning the last value. I'm not turning the total sum. This is how I get around that. Define an empty list and always add stuff into that empty list. So now we'll go ahead and we'll let this run once again. We're still just returning 1. It's only returning out that 1 value. If I wanted to return something else, I could call for points, right? It's an empty list. I could call for I, right? I could call for I and my points all inside those brackets to say I'm typing a list. All right. Now we're going to start to insert where we really need our imperative. We're going to type a while loop. All right. So we start with the command while. Then once that happens, we've got to open up our brackets to define what we want to sort of watch. So while I is less than max attempts, close that out. And because we've started a while loop, we then need to insert another curly bracket. And then we can start to say I equals I plus 1. I like to get that out of the way right away, because if you don't, you can wind up in an infinite loop where it will continue going and going and never actually getting anywhere, right? And so now you can see when I return I, before I had this in there, it returned just that initial 0. Now it's going to run that number of attempts 10 times and add that 1 value to it. Next up, we need to type up the code to find those points at parameter. So we're going to use a surface, point at parameter. We'll define surf as the surface that we want to be, and then we're just going to bring in that surface from outside. Then we need our UV parameters. We use the math.randomList. And I'm just going to use the target for the number of points that we're going to sample, and then math.randomList target as the second. And then we have to make sure we end that with our end of character routine. And what do we got? We've got an error, right? The variable surf hasn't been defined. I either have to define it up above, or I have to define it before my code starts. And that means I can now take my surf in. And then this is going to return a point at parameter. We're going to call this points to test. And the nice thing with DesignScript is, unlike a lot of other languages, it's really fluid for what you can do with space. So it can help to sort of go through and set your stuff up so you can sort of see when your functions start, what's happening inside, anytime you start to do a lot of inline segments like this. Now from here, we've got to start testing out if content sort of hits. So our actual points are going to be equal to geometry intersect, do my points to test, intersect, surf, right? And that's going to check if these two pieces hit. That'll return a Boolean yes or no statement. We'll let that run again. We're still running through. Notice I'm clicking out to make sure this runs because I still haven't saved. And if I crash, that would be pretty traumatic at this point. We'll go one more level deep before we do that, do actually save. List.filter by bool mask. We're going to use that same grain of sand effort that we talked about before. So there's the mask. We're going to filter out our points to test by that other function that we wrote. We'll go down one more level. And this node, the filter by Boolean mask, there we go, returns two different outputs, right? So if we want to narrow it down to just one, the results of this are actually a dictionary. So what I'm going to do is I'm going to refer to the in output. So just the points that intersect the surface. And then I'm going to say P&TS equal list, come on, join P&TS, the previous list of points, and my points, which should be just the ones that intersect my surface. And we've got an error message. List.join is not a static method because I forgot this actually expects a list of inputs. Run started, run completed, still returning null. What do I got here? Points equals list.join P&TS, P&TS. Points is spelled right. I've got a misspelling somewhere right there.
INT.
INT, not in my list of points. Let's try returning just my points. This is where the debugging gets fun. Completed with errors. Points hasn't been defined. Anybody else sees any spelling errors, let me know. Still returning one. Let's cut this out entirely and comment this line out. Points equals list.filter by bool mask.
Joys of live coding.
Yep. To test geometry does intersect points to test surf when completed, and it's going really slow, which likely means Zoom is stopping me from working. I'm going to go ahead and do a save, and I have a feeling this is going to crash here shortly because I'm coding live.
Side note, Zoom makes everything funky for some reason.
We're going to do this. I'm going to go ahead and close that up, and we will open up the version that I wrote just before the session today. Spelling matters except for in file names. All right, so you can see here we've got our point test, our surface, filtering by our in list. When I run this and zoom out so I can actually see everything. Oh, I have to turn on my geometry display. Sorry for that. This is now going to basically run through and sample not just I times as long as I is less than max attempts, but it's going to do so as long as the count of points that I have is less than the total value, and we will always have 1,000 points on the surface. Even if I change the size of my surface, we still have 1,000 points, or we tried it 10 times. Is there a way of autosave backup in case of crash? Great question in the chat. backup file is saved to this particular location, so you can always find that. It doesn't necessarily save if you haven't yet done your initial save. Keep that in mind, and don't be like me and don't sort of never actually save, Dynamo core backup.dyn. That's not going to be as reliable as if you actually save it out as livedemo.dyn.
Yeah, and the same as anything with any computers, if you want to be guaranteed that you're not going to lose something, I would strongly suggest you start saving your things when you don't want to lose it. But we do have a backup in Dynamo. I believe it's every 5 minutes. It's going to take a save backup of your file or of your graph. And that means that you should be able to access that from the backup save location. It's just going to be the latest version of your graph as a backup. It'll overwrite itself every 5 minutes.
Yep. Great call out. All right. So sorry I didn't get to code that all live from scratch in the 10 minutes that I'd allotted, but hopefully this is useful for everybody. You can come back and you can see it. I'm going to zoom in so that you can try and recode this if you wanted to as needed from the video. This is really, really useful again for a lot of different stuff. I've used this to help landscape designers sort of get random population and planting beds, all sorts of other kind of content as well.
Cool. And so we had a question in the chat previously, all the way up top from David, who was asking, what are their benefits to using DesignScript versus Python? Like, when is it better to use one than the other? I wanted to answer this live and get Vikram and Jacob's input on this as well. I think Vikram's already talked about this a little bit, when you can start to weave in associative and imperative into the same set of information, you do gain a lot of power. From my perspective, so DesignScript lives inside of Dynamo. There's one or two other places you can potentially experiment with it outside of Dynamo, but generally speaking, it lives within this ecosystem. Python is a massive language that is used in many different places. So there's lots of resources out there. Dynamo has a special interaction with Python, so there'll be some slight syntax changes when it comes to how you push the information from Python back into the Dynamo graph or take it in. But generally speaking, we have access now to Python 2 and Python 3, so you have access to basically the full gamut of the Python world. There are some special ways you have to actually install Python modules to get access to them if they don't get shipped out of the box. The caveat here really is that both of them have their own strengths and weaknesses. Generally speaking, you are learning DesignScript by default when you're starting to place your nodes, because you're starting to think about and understand how the nodes are named, which means you kind of already know how it's going to work inside of DesignScript to a certain degree. So I would suggest, if you haven't dabbled in any coding language whatsoever, DesignScript is a relatively easy entry point. So it's somewhere where you can get your feet wet and start to understand some of the key concepts of just any programming language, which DesignScript also utilizes. So what an object type is, how to start doing some looping operations, at least conceptually. There's some minor sort of differences when it comes to how they're written, so syntactical changes, but generally speaking, it's a really good entry point. So it's the way I first started learning to code inside of Dynamo as well. And then I jumped rather heavily into Python after that. I don't know, Jacob or Vikram, if you wanted to add anything to that.
Yeah, so, go ahead, Vikram.
Okay. I haven't really dabbled much in Python, but my journey after DesignScript, I haven't given up on DesignScript though. I'm still obsessed with DesignScript. But to me, the transition from DesignScript seems to be more towards, I'm inclined towards functional programming. So I'm not restricting myself to just Python, DesignScript, C#. I think F# is something that is a beautiful language, and that is a lot more related to, say, DesignScript. The thinking is similar. I mean, it works a lot better with lists and things like that. So if you're going to restrict yourself only to Python and DesignScript and the discussion only to that, then I think Python, simply because it's a universal language and it's not specific to a certain, what you call, I don't get the correct term right now, but it's not restricted to a certain field. There's a lot, I mean, you have a lot more resources available basically, and you can do a lot more with it. But if you're going to restrict yourself to just Dynamo, and if you're looking at not looking at its functionality with respect to some software like Revit and things like that, and looking at it purely to generate geometry and stuff like that, I think DesignScript is very, very competent. I think it is adequate.
Yeah, I agree. 99% of what I see people doing in Python and other stuff, you can, pretty readily code around, unless you're calling a very sort of complex external library,
Exactly.
which you can't just quickly pull through imperative code and rebuild on your own. But generally speaking, if I don't have to access the Revit API directly, if I'm just going to be doing stuff kind of on my own, I tend to stick towards DesignScript. I am seeing a little bit more sort of value in there, in that I don't have to strictly define what the input structures are. If you feed a nested list into a Python node that was developed to have a single depth list, or you feed a single item, or you feed an n-dimensional list when it was meant for a single item, it's really, really cumbersome to sort of figure out how to flex your Python data inputs to make that work without turning it into a custom node. Whereas with DesignScript, you can do that in your canvas, work it out before turning it into a custom node without ever having to worry about how to manage that content. So there's some real sort of benefit right there with the list at level, which we didn't even get into in the session today. And we only have 3 minutes left. So I think this will have to be the last question.
Let me just put in one word, which is a major advantage of DesignScript to me, are replication guides. Yes, it's not very easy to master, but they are magic, believe me.
Yep, absolutely.
Agreed.
And Python has no replication guides.
True. All right, so you want to let us know what's coming up?
All right, Sean, give me 20 seconds. So we have these sessions running every 2 weeks. The next session that's going to come up is AU Sessions of Note, where Jacob and I are going to talk about cool things you can watch at AU this year. And then we're going to talk snakes on a Dynamo plane, which is a reference to Python. So we'll actually be talking about Python the session after that. And then the difference between Dynamo things, which is another play on words, which is talking about custom nodes. So those are the next 3 sessions upcoming. And there's going to be more to come after that.
Awesome. Well, thank you guys, and thank you, Vikram, for joining us today. I always learn something. Thank you. We're going to wrap up today, but don't leave. We're going to get you a survey in the chat. Take a few moments to just answer it. It's quick, it's brief. It helps us form what we're doing moving forward and how well we're doing. But I want to give you also a few resources in the community. Next, please, Jacob. Yeah. You can explore the many ways to connect in the Autodesk community, including the global network of user groups in the Autodesk Group Network. It's our industry-focused communities helping your colleagues solve business challenges together. The Autodesk forums, of course, and staying connected with us on Twitter. So thank you everybody for attending. I hope you also learned something. It was highly interesting reading the comments in the chat and trying to understand those. Like I said, I learned something every time. I am the dumbest person in the room in these sessions. This is awesome. I love this. So we welcome your feedback. Make sure to do that survey. It really does help us, and continue to stay connected in our Autodesk community. And we hope to see you next time. And I'm really interested in the snakes on a plane. Yes.
And thank you, Vikram, very much for joining us today. We really welcome your expertise and knowledge on DesignScript in particular, as well as the rest of Dynamo that you bring. And thank you for being such a wonderful member of our community and reaching out on the forums and helping so many people.
Thanks for your kind words, Sol.
Cool. Thanks, everyone, for joining us.
Yeah, take that survey, please.
Yeah.
Thank you.
Yeah, thank you.
Catch you later.